Actually, let's look at this question, which was taken from the year 1998, paper 2, question 7 of the A-level paper. So computer can give independent observation of random variable x with probability distribution given by when x gives you 0, right? X gives you 0 is 3/4 of the time. When x is 2, this is a quarter of the time. It is programmed to output a value of for random variable y defined by y is x1 plus x2. All right, and x1 and x2 are two independent observation. Tabulate the probability distribution of y. Show that EY is okay. I think this is pretty okay. Just understand that. Okay, so the main thing is I know that 3/4 plus 1/4 is exhaustive. Mean you say they are just like 100% of the time, right? So and y is defined as x1 plus x2. We usually will encourage students to draw out the table so that you get a good bird's eye view of what is going on. Like so x1, you can have x equals to 0 or 2. This is 0 or 2 as well. Okay. Then after that, you need your y to be x1 plus x2. Right. So x1 plus x2. So essentially what I'm gonna do is I'm gonna fill up in this table here. This is x1 plus when x1 is 0, x2 is 0. This will give me a y value of 0. 2 and 0 give me 2. 0 and 2 give me 2. 2 and 2 give me 4. Okay, so that's about it. So if I were to give you a distribution table of y, probably the distribution of y, what happens if y could take 0, 2, or 4? So these are the 4 outcomes that we could get. So this case here, what we get is 0, 2, and 4. Okay, so to calculate the probability shouldn't be too bad. So to calculate the probability of getting 0, what we know is to get a 0, the probability of getting 0 here is 3/4. This probability getting here is 3/4 as well. So getting 2 is 1/4 and 1/4. So to get this 0 here, what we need to understand is that taking 3/4 times 3/4, okay, there will be 9 over 16. So 9 over 16. Then to get 2, it will be 1/4 times 3/4 to get this 2 here, and also go 1/4 times 3/4. So it's twice of 1/4 times 3/4. For the last one, similarly, to get 4, we just take 1/4 times 1/4, which is 1 over 16. So this is the probability distribution of y. Okay, so tabulate the show that EY is 1. So we're just gonna show EY. The expectation of y is just weighted average, right? So it's 0 multiplied by 9 over 16 plus 2 times 3 over 8, then plus 4 multiplied by 1 over 16. So this will give us EY equals to 1. The expectation of y is equals to 1 shown. Okay. So let's look at the next part. The random variable t is defined by t is a y square. So find the expectation of t and also show that the variance t is 63 over 4. Okay, great. So let's see how we can do this. So I think now we just try to distribute the to put the value of the probability distribution of t. So essentially you need to square it, but you don't square the probability. Okay, so y. So now t is given by, okay, let's just draw it out. What I get here is t. So now pt equals to t will just be the same probability. Okay, so when t square, so this case, so you see this is t square. So when t is given by y square, sorry, so y square, so this 0 square will be 0, 2 square will be 4, and 4 will be 16, right? The probability, when you copy it down, it will be the same probability. You don't change the probability because that is the probability attached to that discrete value there. Correct? So you don't change it. So this is how we do it. So now this case here, to find ET, what we get is actually just 0 times 9 over 16 and so on, right? So the expectation of t is 5 over 2. So now to find the variance, what we need is ET square, which is actually just 0 square times 9 over 16 plus 4 square times 3 over 8 plus 16 square times 1 over 16. That will give us 22. So in order for us to find variance of t, we know that is the expectation of t square minus of the mean of t, then we entire thing square. So this is 22 minus of 5 over 2 square, right? That will give us 63 over 4, which is good. This is what we want to show. Shown. Okay, so let's look at the subsequent part. Now the subsequent part, we told a computer program is produce a large number of n independent of values of t. So meaning t1, t2. So you have this just means you generate t1, t2, t3 all the way to tn. Okay, and to calculate the mean m of this, we'll find the smallest n such that pm less than 3 is big. Oh, okay, great. So let's look at this. So all we want is the mean value, m of this value, mean of these values, right? So you need to find pm less than 3, which is more than 99% of the time. So what it means is this. So mean value m is given by t1 plus t2 plus t3 all the way to tn. Okay. Then we divide everything by n because that is the mean value that we're looking for. That's it. So once done, well, we know that since n is large, we know the expectation of t is actually, what do you call it? Expectation of t is actually 5/2. And the variance given by this guy here, which is 63/4. Okay. So because n is large, we could use central limit theorem. I think the key word here is always look at calculate the mean value of n, find the small n such that this is so you it's a discrete, and you want to find the probability of a very, very large sample, right? So the keyword is mean, and also like n large independent. Sometimes you'll say approximate the value. Okay, so this will be by CLT since n is large. M will be approximately 5/2, 63/4, and approximately. Okay, that's it. So then what you need to find is you want to find the smallest n such as pm is less than 3, and at least more than 99% of the time. Now you can use table of values. I would suggest using table, but we could also use inverse norm, not an issue. So I'm going to just use inverse norm here. So pz less than 3 minus 5/2. You could use table of values. So this is 63/4 divided by n. So I'm going to use standardization, then after you use inverse norm. So let me just illustrate this to you. So say if you have a standard curve here, then you want, let's say this is shading on the left side is 99%. So this will be 3 minus, this is your boundary, right? Divided by 63/4 divided by n. Okay. So this area here is your 99%. Okay. The question now is, if it's exactly 99, this will be the boundary. But the question now is you want it to be more than 99. Okay. But if you move this boundary to the left, you'll definitely be less than 99, right? Then you should move this boundary to the right, right? Because if this boundary were to move to the right, you will have more, this area, shaded area here will be more than 99. Okay. So that's the idea. You want it to move to the left side so that you can get more than a 99% shaded on the left of this boundary. So an inverse norm, okay, let me just draw this up. This guy will be here. Inverse norm, if it's exactly 99% inverse norm, this will be 2.32634. Okay, so if it's exactly 99, is this boundary here. So this boundary has to move to the left side. So from GC, 3 minus 5/2 must be bigger than 2.32634. Okay, let me just write it down. Then what we need to do is just solve this inequality here. So it should be fine. So by just arranging the inequality here, solve it. So hence the least of n, right? We just least of n. Smallest value of n is 341. So that's how you do this question here proficiently. Okay, of course you can use table values for this question here, but this is a 1998 paper question, so I believe there's no GC back then, so we're just going to use standardization. Okay, so that's how you do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.